Good evening, people, and welcome to the AS mock exam revision session. You've got me for exclusively for 2 hours, and we're going to cover everything that we're going to need. I say everything. Other things might be included. All right, I'm going to get through as many things as we can for our mock exam. So that's next week. I hope you're all ready for it. Hope you've all been revising. Give us a hello in the chat if you feel inclined. This is between us, me and you on the other side. We're going to get through lots and lots of revision. I know you've already been working hard. Hello, Waleed. Akib, oh, look at this. See, this is my group. I say my group. Mine and Matt's group already. I knew they'd be here. Where is everybody else? Interesting. And there you go. Yeah, new Tougher Joe beer. See, clearly my class is going to do the best. I can tell. I can just tell. Okay. Now, lots to get through. Lots to get through. And this is, what you're looking at on your screen, this is everything that we've got to cover in component 1. So that's your theory paper. All right. I have put in here a little bit as well, a little bit of component 2 stuff, so that you're used to this coming up to your exam. We've got paper 1, which is all your theoretical topics. We've got paper 2, which is mainly your on-screen programming exam, but it has mostly chapter 9 in there. So if you're looking to revise on the mock exam this time consists of theory questions and also some programming questions, but you will not be expected to program in this mock exam. All right, but you will be asked theory questions on some of the programming topics, if that makes sense. So we've got hardware and communication, logic operations, data transmission, data representation, data types, and data structures, followed by algorithms and programming. Inside that, so far what you've done in your class is you've done topic 1, topic 2, topic 3, 4, 5. You've also covered topic 7 as well. You've covered topic 8 and also topic 9 with your programming teacher. Topic 11, some people have just started, so systems analysis with your theory teacher and program construction with your programming teacher as well. Some people are getting to that or just started, and some people have even finished it. Now, don't worry if you haven't covered any of those so far, because as teachers, we go at different speeds to certain things. We spend certain time longer on certain things, certain topics, and a big shout out to my teacher colleagues, Matt, Alex, Simon and Becky, all working very hard behind the scenes to make sure that you perform extremely well in these mock exams, because it will give us a real good insight into how much support you need for your actual exam. So check CEDA, check your exam timetable, make sure that you've checked the room. Don't just follow everyone else like an absolute sheep and go to the wrong room. We've had that before. Come on, people, you're better than that. Hello, Ibrahim. Raman. So we're going to get stuck straight in. If people want to ask questions, that's what the chat's for. Fire it into the chat. I'll do my best to get to it. I've got about 9 screens in front of me, so I'll do my best to juggle between. But let's get started on a little bit of hardware and communication. So I will be asking questions throughout this as well, so you can stick them in the chat if you feel so inclined. The first thing we're going to talk about is the fetch, decode, execute cycle. All right. Hey, listen, when you're a teacher, you get paid a lot of money, right? You get paid an awful lot of money. I can afford 9 screens. And they're all huge as well. Like looking at a massive wall of screens. This is the fetch, decode, execute cycle. Now, when I learned this, when I was a student, long time ago, okay, these are the things that I learned here. So, MARPC. Now, before that, we obviously have to get instructions from RAM. And what is the fetch, decode, execute cycle? What on earth is it? It's getting information from secondary storage, loading it into random access memory, then getting it to the CPU to be processed, and that gets sent control signals get sent around your computer system. All right. So the first thing is from secondary storage to load to RAM, it's relatively slow, right? Secondary storage, even with your SSD, it's got a relatively slow transfer speed compared to the central processing unit. So we get it into RAM, which has a faster transfer speed, or we put it in cache as well if we've got it available. So cache has an even faster transfer rate. So the first thing is, the program counter is your component of the CPU that keeps track of which instruction we need to do next. So in our program counter, we'll have lots of different instructions. Let's call it 001, 002, 003, etc. The program counter points to the next instruction that needs to be fetched. Then that gets passed over to the memory address register. So 001 goes into the memory address register. Now we go into RAM, where all our mailboxes are. Mailboxes, 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 mailboxes. And we go and we get the data from the instruction that the memory address register is holding. And the contents, or the data at that memory address, is loaded into the memory data register. Now the memory data register then passes the information over to the current instruction register. And in between that process, we've got this going on here. The program counter gets incremented. It points to the next instruction so that it can start fetching while you are decoding something else. And that's making effective use of time. And that process is called pipelining. Now, the memory address register passing the actual data over to the current instruction register forms the decode phase. So the decode phase is when the current instruction register tries to work out what these commands are. And if you've ever seen some assembly language commands, you've got things like LDA, STA, HLT, addition commands, subtraction commands. All that kind of stuff happens, and the current instruction register says, oh, wait a minute, you're expecting an INP, you're expecting an input from the user. Let's go and send control signals to get that sorted. Now, the current instruction register can't just send control signals and talk to peripheral devices. So what it does is it uses the process, uses the control unit, because it sends control signals around the PC. Now, how do we get signals around the PC? How do we get data from the MAR to the MDR? How do we get information from the PC to the MAR, etc.? We use very, very small copper cables, and they're called buses. Okay? Now, once you get through that process, the control unit sends the signals around the computer. That could be an output to your monitor, it could be your printer, it could be waiting for more memory from the secondary storage device, it can be waiting for an input from the user, etc. So that is the fetch, decode, execute cycle, and it's worthwhile putting this together. So when I picture this, I literally write out PC, passes its contents, oh, it's doing this thing again, I hate this, goes to the MAR, MDR, CIR, and at that time as well, the program counter, that's not a P, program counter +1, current instruction register decodes, and then passes it to the control unit for execution. So that's execution, that's your decode phase, and this is your fetch stage. Okay? So you're going to have to be able to explain the fetch, decode, execute process of loading the contents of RAM onto the CPU, and that'll be worth about 4 marks. Okay. Now these slides here explain what these components are. So the central processing unit contains all the different components, but it is the brain of the computer, and it's very complex, and it calculates billions of clock cycles a second, crunches unbelievable amounts of information. I don't know how we got here and how complex they are now, considering where we started not long ago, relatively a short time ago. These were very, very slow and poor, But processor designs, they are so complex and their architecture changes all the time. Intel and AMD are bringing out processors every year and upgrading. We're on, what are we on now? i10, 12th gen, there's just so many processors out there and they do so much. Now, the components of a processor, they are made up of the arithmetic logic unit, control unit, and registers. Now, in your exam, these shapes are important. So if you don't know that the ALU is in a weird-looking V shape, yeah, then you need to practice that and get it on a flashcard and learn that, okay? Now, these shapes matter. Inside the CPU, which is this grey box around here, you have three components: the arithmetic logic unit, the registers, such as the program counter, memory address register, memory data register, all that sort of stuff is in there. The control unit itself just sends signals out across the control bus. So control unit, control bus. Now the grey one, the grey arrow here, uses the address bus and the data bus. That is how we send addresses and data out backwards and forwards between random access memory, between our input devices, and between our output devices. Welcome, Mellow. Don't know who you are, but yeah, welcome. Now, each job or each component has a different job, does different things. Also, one thing that we haven't mentioned is the accumulator, the ACC. It's a special register that is on the arithmetic logic unit, and its job is to basically increment the program counter or do any mathematical or complex calculations that we need. And this, what you're looking at, is the von Neumann architecture. In exams, you will normally see one of these scribbled out, or all of them scribbled out, and it might have A there, it might have B here, and it might have C. And it might say, explain the component that is C. So you need to name it, and you need to explain it. So the arithmetic logic unit is responsible for all the calculations and logic operations. And what calculations, I hear you ask? Floating point, integer division, while logic, comparison tests such as greater than or equal to, greater than equal to, etc. And for anyone that does electronics, that diagram will obviously make sense to you. Yeah, that is logic gates. It's an architecture diagram. Loads of different gates, lots of different logic, NANDs, NORs, ANDs, NOTs, AND gates, yeah, all that stuff, all connected, lots of logic. The control unit, it's a key part of the processor because, like I said before, it sends control signals around the computer. It uses the motherboard to do it, and the motherboard has lots of copper cables, control buses on there, and it sends things around. Now, what it does is it synchronizes instructions by using the processor's internal clock. So when I say clock cycles, that comes from the control unit, and it makes sure that it sends data in line with clock cycles. Now, the more clock cycles per second, the faster your processor, the more you're gonna pay for it. Now, registers, I've already talked about those. They're small blocks of memory that are used as temporary storage. The next instruction that comes in, the registers get changed. So the temporary storage runs, I won't say at the same speed, but a similar speed to the processor, and it has to do that in order to send data backwards and forwards between it. And the processor contains lots of different registers, like special purpose and general purpose registers, like our program counter, MAR, MDR, that sort of stuff. So machine code instructions can only work if they have been loaded into registers. That's why one of the best things you can do is install more RAM. It's not that expensive in the grand scheme of things, and it's much less expensive than installing a processor. So get yourself some more RAM, but make sure it's compatible at the transfer speeds, because I've seen that mistake made before. No, I've not done that mistake. I'm not an idiot. Hello, Maruf. Good to see you. Well, not see you. Good to read your message. Registers. Oh, yes. All right. There are registers, very popular in exam questions to see, explain what this register's for. Hello, Logan. You're not in my class, but I'll accept you. I'll accept you. Now then, program counter, MAR, MDR, CIR, ACC, they are all the different types of registers that we use. Now the program counter, I won't spend long on this, people. I won't spend long. Program counter stores the address of the next instruction. That's its job. Keeps track of things. So there you go. There's a robot graphical representation of a program counter. Now what happens if we have to change instructions all of a sudden? What happens? Well, the contents of program memory has to be put somewhere, gets put in a data structure called a stack, and we load some other data in to run another program, because we know what you're like. The generation of today, they want things now. They want things immediately. And that's what your processor tries to do. It tries to serve its master as best as it can. So it will load different instructions. It will change instructions in and out, etc. So it's an incredibly complex thing, the program counter. Incredibly complex. Sometimes, is it boring doing the thing? No. No, it's not. Computer science is not boring. Sorry, I've lost my train of thought. No, I haven't, because I'm a professional. So, the program counter, as it goes through, it needs to change rapidly. And sometimes your computer may freeze. It may stall. That's because the program counter has lost its direction. It doesn't know what's going on. All right. So, program counters get incremented, and we want to try and avoid something called a jump command. Jump commands are when you change the direction of your processing. And you must complete all of the different parts. Just go back to the robot man there. You must complete all parts of the instruction before you can run or execute on the control unit. So you need to load them all in to the processor first before you can run the instruction. Okay. Now, memory address and memory data registers. The MAR obviously contains the address. Obviously. Anyone else? Can anyone else hear me? Maybe you should turn your speakers up. Is the volume good enough, people? I'll just pause. I'll just wait there. Is it just mellow that can't hear me? Oh, the volume's fine. Oh, see? Oh, look at that. Yeah, hey, we're not messing here. This microphone, this is a Rode microphone. This is what happens when you get 1K subs, people. All right, cool. I'll carry on. So the MAR contains the address of the instruction. The MDR contains the data of the instruction. Okay, so the fetched instruction or data is stored in the MDR. Now we fetch it from RAM, because fetching instructions from memory can be a slow process. The processor always tries to fetch one instruction ahead of the one it's currently working on. And that's that process there called pipelining. That's when we try and get an instruction while we're fetching another one. So we get an instruction while we're executing one, should I say. All right? The current instruction register is the decode part. So the instruction, as the instruction in the CIR is being decoded and executed, the next instruction is being fetched. And again, we're trying to speed up the process of the von Neumann architecture, people. And any instruction that performs a calculation will make use of the accumulator, like the program counter. The program counter. Now, those commands you're going to learn a little bit more next year, if you make it, right? So you're going to make it into the second year, and I'll teach you assembly language programming. It's a nifty little skill. If you're in electronics, you're probably already doing this anyway, but assembly language programming, so these are assembly language commands here, ADD4, add 2, subtract, etc. All those commands get put together extremely, they're so fast, but we don't program in assembly language anymore because people are just not as good as they used to be when it comes to programming, unfortunately. Sorry about that, everyone. Everyone's using ChatGPT now, so, you know, is what it is. So buses, a couple of definitions here. You can screenshot this if you want this for your notes, etc. But the address bus, what it does is it transmits addresses in RAM of the next line of the program code to be fetched. Okay? So it sends data, memory addresses all over RAM to different mailboxes, and it sends you to the mailbox to collect the data. All right, it transmits the address of RAM locations or input and output ports where data is stored or to be loaded. Like right now on broadcasting, it's probably going through port 80, which is my internet port, and it is on most computers. The college has lots of different ports that it's blocked to stop people getting in. The firewall controls these ports, etc. So that's what it's talking about there when it comes to input and output devices. Data buses, they transfer program code between main memory, that's your RAM. Yep, primary memory, that's RAM. Secondary memory is like hard disk drives and that sort of stuff, and the processor. And it also transfers data between the processor and RAM memory, or its inputs and output ports. Okay, the control bus, just for the control unit, it sends control signals from the processor to main memory or the input and output ports to initiate data transfer. And it carries interrupt signals. Interrupt signals to the processor to indicate that the hardware or software requires attention. Like, I need an input, save the file, open the file, delete something, rename this, right? They're all interrupts that are provided. So, do you want my advice? I don't care. You're going to get it anyway. So this is what I would learn. I would commit that to memory, have little descriptions, understand what those acronyms are for, and which part they lie in the fetch, decode, execute cycle. And that's that, people. I'd also learn the diagram and consider what problems that diagram has. The von Neumann architecture has been around a long time, but it does suffer from something, people. It suffers from bottlenecks. Ever heard of a bottleneck before? Can anyone tell me how to fix a bottleneck, please? I'll pause awkwardly. Cache memory, thank you. Waleed, they share the same one. How about that? They share the same one. Data and address buses share the same copper cables to send data backwards and forwards between input devices and primary memory. But when it's transmitting data, it'll be the data bus. When it's transmitting addresses, it's address bus. Okay? So, bottlenecks, people. We fix a bottleneck with cache memory. What does a bottleneck mean? It means data struggles to move at the relevant speed because everything's trying to get out at the same time. So, cache memory. What is it? Well, which one's slower? Random access or processors? So CPU. CPU is well faster. What year the mock paper from? It's from 2018, 19, 20, 21, 22 sample, 2020 sample, 21 additional paper. It's from every paper. Ridiculous question. As memory runs a lot slower than the processor has to wait. So the processor's saying, give me data now. And the RAM's like, whoa, I'm giving you data. I can't load it fast enough from secondary storage. So it's like, the processor's like, come on, I'm hungry give me data. Give me the data. And then RAM's like, oh my goodness, I can't, we're so slow. Right, so we need something in between. We need a middleman in between random access memory and the processor. And that's called cache memory. Cache memory. Now a clock cycle, because the processor is going so quick, it actions clock cycles. The more expensive, the newer your processor is, and the higher number it is for Intel, for example, i7, i9, that sort of stuff, it will do more clock cycles per second because of its architecture. So the transistors have different logic that do things faster. So a clock cycle is, the definition is the amount of time taken between two pulses of an oscillator. An oscillator is like a crystal. You can get it you have them in your watches and stuff like that, right? Because they're very steady. So the overall efficiency of the computer system is reduced, and a lot of time's wasted because of the speed mismatch between memory, primary memory, and the processor. So that's the von Neumann bottleneck in a nutshell. Okay. So you can have lots of different levels of cache, and cache memory is small sized. It's volatile, which means when the power's turned off, the data is lost. It provides high-speed data access to a processor, and it stores frequently used programs, applications, and data. So, level 1 cache, physically located where the CPU is, right? It tries to be as close to it as possible to reduce transfer time. We're talking nanoseconds, but it makes a difference. All right. Extremely fast, more expensive, located closer to the CPU. Okay, level 2 often has a higher capacity than level 1, but as a result operates more slowly. And then level 3 works to improve the performance of level 1 cache and level 2 cache, but it's typically shared by all cores of the processors, and it's, again, not as fast. Might not be located directly on the CPU itself. And that's where you can see, at the bottom there, you can see shared level 3 cache down here. Whereas each core might have some dedicated level 1 cache or level 2 cache, depending on what it's doing. Now, in order to improve the speed of what we're doing, nowadays we have multi-core processors. And one of the most common types is a dual-core, quad-core, octa-core now, but most of us deal with quad-core processors at the moment. So in parallel processing, when 2 or more processors are working together to perform a single task, we call that parallel processing. And the task is split into smaller subtasks called threads. And each thread can be put on a different processor, and that means we want to keep the processor in action, working as hard as it can for as long as possible. If your processor sits idle, you are wasting your money. So, that's just a little Bitcoin mining tip for you there. Make sure your GPU is always running. And it does reduce the life of your GPU. Right. Parallel processors increase the efficiency by allowing us to work on different parts of processors. But programs have to be written to utilize the threads, and that is a very, very complex task. And most programs aren't written for that. But it would be very beneficial if it was, to be honest. So for example, in like a game program, rendering every pixel on the screen can utilize parallel processing, but calculating the game score is a straightforward sequential process. Now, if you have a sequential process that has to be run from start to finish, that must be placed on one processor. It cannot be parallelized. It cannot be split up. Okay, serial tasks have to be done on one processor alone. So you can get very complex architectures with lots of parallelism, etc. But no program can be divided in its entirety. No program. Right. That's it, people. 28 minutes done already. My goodness. I've got a lot to get through. Right. Fly through these. Does anyone know what OCR is? OCR? Not the exam board. OCR. Awkward pause. OCR. Type it in the chat. Engagement. No one knows what OCR is. Optical. Character. Recognition. Okay? Optical character recognition. You might have seen these in school or college. I know people have these. And basically, what its job is to convert printed text on paper into editable text documents. Sometimes you might have seen special pens that people have that read it out. If you suffer from dyslexia or stuff like that, or even dyscalculia, which is like a number issue, that processing numbers, you can have these special pens. But OCR is what we call a post-processing step, and that occurs after. So it gets processed after the document has been scanned. Now it performs pattern matching. So you scan a letter or someone's handwriting, and I've seen your handwriting, people. Even if you're not in my class, I've seen some of your papers because I've marked them myself. Some of them are handwriting is horrific, but we are computer scientists. Now it performs pattern matching by scanning the images and checking it against a database. Now, OCR is wonderful, okay, but it's done by comparing the binary data, and sometimes it does get things wrong. If no match is found, the shape is skipped. So you can get errors in there, but it's very complicated for a computer to understand shapes. So when you complete a capture code, or the I'm not a robot stuff, what you're doing is you're actually training optical character recognition systems so that computers can read letters. Nowadays, you've got the image ones where you select all the images of a boat, select all the images of lampposts and cars. You're training artificial intelligence or recognition systems for cars and automated cars and stuff like that. Did you know that? Interesting. Now, OCR sometimes gets it wrong. Great. The next thing to look at is OMR. So you've seen these before. These are the traditional registers from my primary school. I remember this years ago. Optical mark recognition is based around a predefined form. So that's one disadvantage. You have to have a predefined form. So the form has specific parts for someone to fill out by putting a thick black mark on them, and then a special reader, scanner, will read the form in that format. Now, what issues we have? Look at the form. Right? What if you sign outside the box? What if you mark something, get it wrong, try and mark it again, etc.? So if 2 marks are made in the same section, it only accepts one answer. What if you get it wrong again? 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 So some examples of OMR is multiple choice exams, registers, but they're not suitable for any written form of communication, which is a nightmare. An absolute nightmare. It's rare. I thought you weren't coming till 7 o'clock. You little liar. Anyway. Last one. Magnetic ink character recognition. Okay? MICR or MIR. So magnetic ink is the classic checks. Now, you won't know what checks are because nobody uses checks anymore, really. Nobody uses checks anymore. But these checks have a special iron oxide ink on them, which is magnetic, that is read by a special scanner, and it is very expensive, but it was worthwhile for banks because they were putting in hundreds of checks, thousands of checks a day, so it was much faster for them, right? But regardless, whatever's written over it, it can still read it, which is good. And it's almost exclusively used for checks because of the high cost of the reader. I've not seen one ever in real life, so that's how frequently they're used. But people used to pay by checks. These little pieces of paper, which is basically an IOU, people. An IOU. Now we've got contactless payments and all this stuff. Do you know what 2 types of touchscreen are? 2 types of touchscreen. Any ideas? 2 types of touchscreen. iPhone, Samsung. Is this guy for real? What the hell? Yeah, capacitive and resistive. Wonderful. Now, to cut a long story short here, people. To cut a long story short. Resistive is your older screens, not as good quality, cheaper, usually plastic. And what you needed to do is actually make an indent between 2 layers. So you push the first layer into the second layer, which basically records a touch. Now, the bad thing about that is it can only record one touch it can record multiple touches, but you can't do things like gestures. You can't work out what swipes are, etc., or 2 fingers swiping outwards to zoom in and stuff like that. But they are cheaper. Okay, they're made up of 2 transparent sheets, and the sheets touch each other, and it records a voltage at that position on an X and Y coordinate, and a certain amount of pressure is needed to make sure that happens. They don't provide a sharp image because of the plastics that they use, so we go for capacitive screens nowadays on our fandangled iPhone 27s. 69K, wonderful, thousands, million bits, pixels per image, so that you can snap tube each other. So capacitive touchscreens, made of glass, controlled by electronics, and they make use of the body's natural ability to conduct electricity, because we're made of water. So sharper images, that's what we get, and that's what people like. They want that sweet, sweet 4K. 144 hertz. That's what we want. That's what we want. Multiple touch points can be recorded simultaneously, and that allows for gestures, but it is more expensive. But people want quality. Capacitive touchscreens make use of both the fact that the human body conducts electricity, and when you touch a capacitive screen, you are actually creating a little electric field. The problem is, what if you've got gloves on? 8K. I wish. I don't get paid enough for 8K. What happens if you've got gloves on? Yeah, new ones are all capacitive nowadays, yes. Even the bendy, stupid ones. Those bend. If you've got, right, listen, this is disclaimer. If you've got one of those stupid phones that turns, that folds or something like that, you should give your head a wobble. Yeah, take off the gloves, people. That's all you got to do. Or get them fancy gloves. You know, with the fingertips that are like woven with like some... Does Drift King _YT have a Galaxy Fold? I'm going to kick you from the chat, my friend. You better state something here saying that you've not got one. Drift King. £3 on eBay. I'll buy one for every student. Alright, so there we are. Also, people like Apple. How much is an Apple pen nowadays? Apple pens. There used to be a song about pen pineapples and apple pens. I don't know if you've heard of it. Someone could put the link in the chat. Now, when you... You're joking me? £300? You know, they made me spit my tea out then. What is that? £300? Voice input. Okay, now, voice input can be used to issue spoken commands. Commands only. So, Alexa, hey Siri, that kind of stuff. Okay? So, don't get voice input confused with vocabulary dictation. Because vocabulary dictation is when you press the little microphone on your keyboard and speak into it. Alright? Now, vocabulary dictation is great because who wants to type? Who wants repetitive strain injury on their fantastic RGB mechanical keyboard? Yeah, if you're looking at mechanical keyboards and RGB now, I've got no words. I've got no words. So advantages to vocabulary dictation. Speech input can be faster than keyboard input. There's no need to learn to type, so it's better for younger users. Less danger of RSI or repetitive strain injury, and it reduces typing mistakes and spelling and hitting the wrong keys. Keyboards, they do take up room on desks, etc. And that's why BlackBerry died, because it tried to put a keyboard on a phone and people were like, I want more screen size, and it died off. They did try and put an electronic keyboard on the screen, but that also was rubbish. Users with disabilities can use speech input. Unless they can't speak, for example. Hands-free advantages, so you can multitask and things like that. And users find talking more natural than typing. But you can have accent problems, background noise, you can have speech impediments and disability with speech, etc. And it can also be difficult to keep data input private because you're chatting on the bus. Yeah, if you're that person that's on the bus and you're playing your music well loud, that's why I drive a car, because you can't be doing with you. You can have homophones as well, such as 2, and 2. The BlackBerry was peak. Okay. Sure. Literally no one agrees with you. Not a single person agrees. Voice print recognition. It's the process of capturing a person's voice print and then digitizing it and storing it on the computer system. My bank has a security word that I have to say. I'm not going to say it because you'll probably just take it off this video, snip the audio, and try and break into my bank. Good luck. There is no money there because teachers pay, etc. I won't go into it. All right? So what is it? It's a great question. I'm not going to answer it. So voice print recognition is often used in security systems where the person may attempt to gain entry into a high security room, and two data items, so the original and the new, are compared. So you take an original recording, you say your special word, and they're compared. And it's actually quite good. I wish, Isra. I wish. You know what? With 1K subs, I will do. That's where I'm at. Now, storage systems. I think that's Google data storage in Finland because it's colder, I think. Storage systems for enterprise. Where do we store things? Can anyone tell me any secondary storage devices that they know of, please? Secondary storage devices? Secondary storage. SSD, yes. Hard drives, magnetic. USB memory stick, yes. That's a form of solid state. Yeah, USB. Magnetic tape, good, nice. Old school technology. Floppy disk. Oh, Tuffagel's living in the 1970s. NVMe, yeah, the new stuff, the M.2 memories. Very quick, very nice. We like that, we like it. So yes, now you can have something like this. This is a network attached storage, which is a just hard drives really in like a networked device that you can basically connect to. But a network attached storage can use something called virtual storage. Now you can use RAID. So RAID basically allows you to back up things on your storage devices. So RAID is redundant array of independent or inexpensive disks, depending where you look. And it's one of the most common technologies that runs behind the scenes. And we have a RAID system at college to basically back up all of our storage systems, and we can combine individual SSDs and HDD drives together to form a big, fat storage device. Now, on our magnetic drives, so our hard disk drives, we need to think about disk defragmentation and disk fragmentation. So files are stored in a computer system over time, turn into this, which is all these gaps in between. As we delete different programs, we remove and leave gaps everywhere we go. Everywhere we go, we leave gaps. Yep, streams being recorded, it'll automatically be published at the end. Now, what we want to do is we want to basically make these gaps straighter, all straight lines as much as we can. So we want to make sure that we realign all of our data so that the read-write head of the disks of the hard disk drive can retrieve our files. So defragmentation is the process where files are physically rearranged on a disk so that they are no longer fragmented and the parts of each file stored together, and it improves disk access. So the speed of that. Okay. Now what about SSD? Solid state drive doesn't have any moving parts, which you should be writing. Should be writing that in your exam. So magnetic storage is not as quick because it physically moves, whereas solid state is electronic. It uses NAND, N-A-N-D. NAND flash memory, and you've probably seen that before from logic operations. It's a knotted AND gate, and it uses the trim command to defragment. Now, you can't defragment on something that doesn't have platters, but what you can do is you can mark areas of your hard drive for deletion. So when you delete something on your solid state drive, it doesn't actually get deleted, it just gets ignored, it gets removed from its file access table. So you can use the trim command to permanently delete those things. All right. Now, we'll look at compression. So secondary storage. I've already talked about these, and these are the three different secondary storages that you can have. So magnetic storage is slower. It has disks, physical moving parts, a read-write head, disk spins, RPM, etc. The faster the disk spins, the faster the read-write head moves, the more storage and the faster it's going to access. Flash storage is all about having electronic NAND flash memory. It's much quicker because everything is at the speed of electricity. Speed of electricity, not RPM. Stupid thing. This makes loads of noise as well. And if you drop it, you're going to kill it. This thing is durable. Shock resistant. Optical drives. What is an optical drive? What the hell? It's an optical drive. Alex Gray says hi. Alex looks awfully like Alan Turing. What's an optical drive? You've probably never used one in your life. DVD and that, yeah? DVD and that. Yep, so CDs, Blu-ray. Blu-ray? So Blu-rays, That's just the light of the laser that looks at it, really. But in a CD, you have pits, and you have lands. So basically, like this. Well, that's badly drawn. But basically, a pit is where a 1 has been drawn. 1, 1, 1. Okay. Laserdisc. PSP cassette tapes in those stupid plastic things. You are that young. Don't even go there. If you were born in 2000 and something, you are a young person. Try being born in 19. Yeah, I was born in the 19s. What? Oh, guess what? The internet and the World Wide Web are not the same thing. Did you know that? The internet and the World Wide Web are not the same thing. The World Wide Web is a network of websites linked by hyperlinks that are accessed through the internet by a web browser. The World Wide Web is not physical. You say you know. I see what you write in exams. Don't even go there. The internet is the physical network of satellites, computers, telephone wires, anything that makes up the physical part is the internet. So when people go, I'm going on the internet, it's like, well, you might be accessing the internet using the World Wide Web. But I've finished correcting people because I'm too old. So computers may be connected through wired or wireless networks. Oh, who'd have thought? Who'd have thought it? You can have wireless networks. At the college, when you move between buildings, you move between wireless access points. That's why your phone reconnects in every single building. You don't have to re-put in your credentials, all right? Now, your phone, in college, we have something called a local area network. The college is still a local area network. Geographically, it's very, very small. Your home is a LAN, so it's a local area network. You can have a WLAN, which is a wireless local area network, okay? Whereas the internet is the best example of a wide area network. Now, how? Servers, you send information all over the place. Servers basically hold lots of information, and when you're using the internet and the World Wide Web, we request data from servers. So you can have something called a client-server network, okay? Client-server network. And for that person, yeah, college Wi-Fi is that fast because we're a part of the JANET network, the Joint Academic Network, so we pay very good money to have really, really good cables, optical cables in there, and it's shared by Manchester Uni, Manchester Met Uni, Huddersfield, etc., Oldham College, Oldham Sixth Form. That's why we get unbelievable speeds. So servers in a client-server network are centralized. That makes them good for updating, editing, etc. And the server is a more powerful computer. That's all it is. That's all it is. Now, the server just responds with a security challenge like a password. I wouldn't give you networking doors. Well, I would give you networking doors because you wouldn't know what to do with it. There you go. There you go. Yeah, you thought this live stream was going to be encouraging, didn't you? Clearly, you've not. Well, you might have met me actually, but you might not be in my class. So peer-to-peer networks. Long time ago, when I was younger, we used to use torrents in order to download software legally, all legal, software, music, etc. But we have something called a peer-to-peer network. So peer-to-peer is when you share between each other, and you can do something called seeding and leeching. So what used to happen is you used to download something off someone else, right? You used to leech off them and download it, and then when you downloaded a piece of software, you used to seed. So everyone else used to seed it to everyone else. So everyone else used to leech it off you. So giving it away is called seeding, and leeching is when you take it off someone. Must all devices be... Yes. If you come off the internet, you cease to be a seed and you can't leech anymore. You have to be online. So I used to leave my computer on for like days and days and days on end. Yeah, if you want to access the dark web, just download a Tor browser and get on it. It's not illegal. Literally just admitting to fraud there. Yeah, piracy. There you go. There, see? Yeah, it's incriminating evidence. Why did you do that? Oh, you're an idiot. Muppets. Oh, well, there you go. Now then, protocols. Are we all listening, people? We all listening to protocols. This is very important. Protocols. They come up in exams. How many times? Over the years. Most years they come up. Most years. All right? So a protocol is what we're governed by on the internet. Right? When we access hyperlinks on the World Wide Web, we are governed by the protocols. The protocols are set up. They are a standard, and it doesn't matter what country you are in. No single person is using a different protocol. Nobody owns the internet. Nobody owns the World Wide Web. It is by the people, for the people. So things like protocols that we need, things like linking a printer to a computer, a mobile phone via Bluetooth, using FTP, HTTP, SMTP, VoIP, POP3. VoIP and POP3, POP3, VOP, Voice over Internet Protocol, is how you ring someone on WhatsApp or you call someone on Snaptube. You speak to them using the internet. That is Voice over Internet Protocol. All right. POP3 is a mail protocol, which is for sending emails, stuff like that. So this stream, well done, this stream is using UDP. So the marks at the end show you how you get 3 marks on this question. So it'll ask you to define what FTP means and describe it. So FTP is file transfer protocols, and it allows the transfer of large files over a network. Okay, if you don't put large files, guess what? You don't get the mark. So you've got to be precise. These are exam board definitions from mark schemes, these people. So do not get them wrong. Like I said to my people, my class now are probably reaching for their flashcards that we created all that time ago. POP3 is still used, yeah. No, it's still used. Now, it's important as the FTP protocol has built-in error checking. Built-in. So that means if you drop packets, you can request them automatically. So if you can't build the email or the message or the request or whatever, because you've dropped some packets along the route along the way, you basically ask and send a request to resubmit them, retransmit them automatically. So that's File Transfer Protocol. HTTP is Hypertext Transfer Protocol. You've heard of HTML? Hypertext. You know what the ML's for? ML? Hypertext. ML? Does anybody know? So we use it for creating websites. So it's for markup language. Very good. So hypertext markup language basically allows you to display web pages in the same way, whereas HTTP allows the transfer of multimedia web pages over the internet. And it's important because the HTTP protocol allows multiple different web browsers. So whatever browser you're using, you're probably using Chrome, it's very popular, using Safari, using Mozilla Firefox, using Opera, using your own Tor browser, etc. I give you flashcards, man. I give you flashcards. My people will tell you. They're physical flashcards there, people. So it allows you to display your website on every browser. Now, that doesn't always happen because Chrome are pretty naughty. They have extra features that you're not allowed to. But you've got SMTP. So this is the first of your mail transfer protocols. All right? So it allows emails to be sent over a network. And it's important because the SMTP provides a standard way of transferring emails between 2 different servers. Server to server. Server to server. Whereas Internet Message Access Protocol, IMAP, allows emails to be transferred between computer systems. Right? So this is server to server. Server to server. This is computer to computer. Either I copied Becky or Becky copied me. I don't know. HTTPS is the secure version. Yes, it offers 2048-bit encryption, which is incredible. Honestly, it is genuinely mind-boggling how secure HTTPS is and how difficult it is to crack. But IMAP is between computer systems. Now, the way I remember IMAP is when you transfer between computer systems, that can be a server and your device and someone else's device, etc., or a laptop of yours and your phone. Your phone doesn't show you all of the emails. It'll show you like 10 or 15. You've got to scroll to the bottom and it updates and then it loads the next 15, so it requests it from the server, and that saves a lot of time. Correct. Computers versus servers. Now, when it comes to DHCP, Dynamic Host Control Protocol, you need to think about IP addresses. So its job here is to assign IP addresses to devices on a network. If you're on a mobile phone now, it's got an IP address. If you're on a laptop, it's got an IP address. If you've got a smart kettle, it's got an IP address. If you have got a smart TV, it's got an IP address. Okay? So every device connected to the network that is the internet and the World Wide Web has to have an IP address, because we need to know where to send data to and retrieve data from. All right? So what happened was, so many devices were coming online. So many devices. And we were running out of IP addresses pretty quickly. So some smart aleck decided, right, well, if you turn your device off and you come off the network, you release your IP address. You don't hold it forever like a MAC address. A MAC address is dedicated to the device. But an IP address gets released again into a pool of IP addresses. Then your friend will join, might take that IP address and be assigned to you. All right? Smash official. Yep, wonderful. All right, so DHCP, dynamic unique IP addresses are allocated and allows addresses no longer in use to be automatically returned to the pool of IP addresses. All right. Now then, UDP, UDP. Right, I'm using UDP right now. So it sends datagrams across the network, right? A datagram is literally a packet of video, audio data. That's it. Sends it across the network. It's got very few error recovery services. So if it has error recovery services, right, it will request the packets again, and you will basically, your video will stop. So if you're viewing me right now and your internet's not very good, right, or my internet's not very good, packets will drop and the quality will worsen. So I might be streaming at 4K, 1080p, it's definitely not 4K, 1080p, etc. And it might drop to 720p because I'm dropping packets, so the quality gets lost. That's what UDP does. So this is important. For example, video and audio streaming protocols are designed to handle the occasional lost packets and need to receive new packets rather than retransmission of previous ones. Okay? 144... I don't even know what I'm streaming at, to be honest. Let me have a look. Oh, 480p. Oh, no. Yeah. 1080, 60. There you go. I've reduced mine down. On my 8th monitor, I've got the stream live. Anyway. Last one. Transmission Control Protocol, so TCP/IP. And TCP/IP is a stack. It's multiple protocols together, and it allows any network computers to communicate with each other. And basically, when I send stuff to your computer, my computer and your computer, we agree on the protocols that we're going to use. I'm now live streaming directly into your home. I think you're at home. I don't know. I can't check without scanning your IP addresses, which I've done, by the way. Now, I send all the information to you, and you send information back to me saying you're receiving it, etc. Yeah, it's FPS. Sending data back and forth, sending data back and forth. We have to agree on the protocols, whether it's UDP, HTTP, IP, whatever. We have to agree on it. TCP/IP creates the stack of multiple protocols, and it specifies how signals are routed and transported around the network, and it reduces the need for gateways to convert signals into different protocols. So we agree. We agree. Yeah, and we do that during handshaking. Right? Handshaking. What is handshaking? Handshaking is the process by which two devices establish their readiness to communicate. That's right. That's right. Now, here's a format question. It's a bit sneaky on this one. Describe the process of handshaking between two devices. So we use these words called SYN and ACK. So SYN is a signal. It's used to indicate the start of an IP session. ACK is an acknowledgement saying, yes, I've got your signal, and you can return. So what you do is you get two devices, mine and yours. My device will say, right, send a signal, send an SYN to device 2, basically saying, hey, do you want to talk? Your device goes, yep, I want to talk. And then you say, do you want to talk to me? I go, yes, I want to talk to you using these protocols. And then my device will go, oh, okay, acknowledgement of that one. Sweet, I'm happy with your protocols. We both agree on our protocols. Let's begin chatting. And that's it. That's what we do. That's what we do. Now, does anyone know what's inside a data packet, though? When we send data across the interwebs. Does anyone know? What is inside a data packet? Data, the classic. Data, yes. What's inside the header? What's inside the footer? Because you're right, they are inside. We've got header, footer, data. Sender and destination IP address. That's worth 2 marks, that, if you list them separately. That's good. Header got destination address. Error checking. Good. Error checking. So we call this a parity bit or a checksum. That's our error checking bits. Nice. Maroof, you're going to do well, my friend. I can sense it. There we are, people. Sender's IP address. Intender's receiver's IP address. Something that tells us how many packets the data's been broken into. We need the number of packets and that number of that packet. So the total number of packets and the specific packet number of the packet that's been received. I won't, Maroof. Don't you worry. I won't. We can live in hope, though, can't we? We can live in hope. Boolean algebra, anyone? Boolean algebra? Let's have a look. That's got us to the end of that one. Look at all that stuff, man. That's got us to the end of that. We've got an hour left. Oof. An hour. Everybody ready for the next bit? We feeling good? An hour's gone like that. Not Boolean. I'll let you vote. What do you want to do next? Willied's found the emoji keyboard. Where do you want to go? Where do you want to go? What's on the test? No problem, Tuffagill. Number 1, number 2, number 3, number 4, number 5, number 9. I can't remember what else. 7? Bit of 7? Maybe? Boolean's too hard. Normalization. How long's test? Have you seen my videos on normalization? It's an hour and a half. I'd genuinely go and watch the videos on normalization. People asking for databases. No, it's not. No. Terms might be. Well, that's interesting. Please tell me you do computer science. Boolean's too hard. file to relational. I mean, if you are struggling with databases, please, I did a full video series on it. So I wasn't planning to cover it on here. That's why it's not yellow. Interesting. Chapter 8, operating system. Maybe parts of operating systems, but again, not a major focus on it. The things in yellow are major focus on those. Do some programming. Do you know what? I'm going to look at chapter 9. Okay, now chapter 9 on here is basically the theory of the programming stuff, and it's always good to recap these because lots of different classes are at different points, okay? But you will not be expected to do programming in this mock exam, like I said at the start. In your paper 2, you'll have one question that requires you to download, unzip, and run a Python project. So firstly, if you are to explain what an algorithm is, it is a set of mechanical or sequential steps. All right, you can just say steps if you want. So it's a series of steps that you follow when you take an input, you process it, and return an output. And it's those steps, it's the method of doing it, which is the algorithm. And use algorithms for everything. Everything. How you get to college in the morning is an algorithm. How you tackle a mathematic question is... That's exactly what it's just the method of how you do it. All right? How do you represent algorithms? Yep, pseudocode might be on there. How do you represent them? Pseudocode is one way, flowcharts is another, and structured English is the third way. Okay? Now, on there, with those three, structured English does not come up. Okay? It just does not come up on your exam. The two there, flowcharts and pseudocode. Now, these flowchart symbols are out of the textbook. And the only difference that I would say, everything else is the same, but this one here, this output, normally this does input and it does output as well. All right. Don't worry, you'll be shown how to unzip Python, etc. You'll have a dry run of it all. Okay. Now, here is some structured English on the left-hand side. 16 steps of structured English. Start the algorithm, set the sum variable to 0, get the first test score, add the first test score to sum, get the second test score, add to sum, third test score, add to sum. It's very repetitive, so it needs a loop in there of some kind. So this is it converted into a flowchart. So what you is you start the algorithm, you have a process that sets the sum to 0, and that's why it's in a rectangle, because it represents a process. You input a value, you add the value to the sum with another process, and you output the sum. So if I write sum in there, that should say sum. Okay? And that's it. Now this thing here represents a loop, but normally these loops need a condition. All right, so while numbers not entered. Now that kind of thing there, that is perfectly legal in flowcharts. You can use structured English rather than specific logic. You can look at something like a linear search. So how does a linear search work? Well, normally we have a data structure that is an array. And remember, I might come back to arrays later on. Fascinating things. You can have a one-dimensional array, one dimension. You can have 2 dimensions or 3 dimensions of arrays. But this is a single-dimensional array, starts at 0, works its way up to whatever. And a linear search takes the first element, says, are you the thing I'm looking for? If it's not, carry on to the next one. Are you the thing I'm looking for? No. Are you the thing I'm looking for? No. Are you the thing I'm looking for? Yes. Excellent. Return it. That's the linear search. You can choose to do the algorithm however you like, but just read the question because it will say using pseudocode or it will say using a flowchart. If it says using a recognized convention, you can do whatever you like, providing it's structured English, flowcharts, or pseudocode. Okay? What I see nowadays is our exam board doesn't tend to say using a recognized convention. Now, me personally, if it says using a recognized convention, I'd go with a flowchart. I mean, they're dead simple, straightforward. As long as you know the shapes, you're going to be all right. So this says start, input the search term. Let's say it's 14. Set X to 0. Has the end of the list been reached? Nope. Does the list at position X contain 0? So is it the thing I'm looking for? Yes. Output it and end. If it's not, increment X by 1. Go up. Has the end of the list been reached? If you say yes, so you got to the end and you've not found it, you just output an end. Okay? Now something a little bit more tricky, or people find tricky anyway, is pseudocode. Pseudocode. And we'll do a bit of pseudocode. We'll do some pseudocode with some of the searches or the sorts or something, I think. Do people want to see pseudocode? People want me to do some pseudocode? Maybe, maybe not. You can let me know in the chat. Now, a couple of things that you see with pseudocode, you'll see begin and end. If you didn't put that in, you wouldn't be penalised, to be honest. Set sum to equal 0. Now, this here, you can either have an equal symbol or a 2, etc. Now, what I've seen in the past is if people are not accurate, right, as long as I can understand what you're writing, this is basic. This stuff here from the textbook is basically Python. That's what it is. It's all written Python-esque, right? But if I can understand what you're doing, you can get your logic across to the examiner, you're going to get marks. We do something called positive marking on this exam board where we don't penalise you for doing things wrong. We give you credit for things that you've done, right? For loops, for I 1 to 10, right? You notice how we don't put range here because we're not writing in Python. We don't use the word range. We say, where do you want to start and where do you want to end? I is a local variable. Input, the word input is used. Input value there, that's perfectly acceptable. You're expecting the person to input a variable. That's it. This is like standard logic. End the for. You wouldn't do that in Python normally. In pseudocode, perfectly acceptable. So, let's just get through a few terms first, and then we'll come back to some pseudocode in a second. So, validation and verification. Do anyone know any validation methods? My theory class today, I mentioned this during lesson time. Anyone know any validation or verification checks that we perform? Good, Waleed was listening today. So not quite a loop, but a length check is correct. Presence check, yep. So presence check is to see if something's been entered. A length check is to make sure that it's between the correct boundaries. So a length check might be a phone number being 11 digits. Range check, yes. So range between, I don't know, being let in for a cinema. So 18 and above. For an 18's film, be right back is not a... no. Format check is one though, like an email address that has an @ symbol or a postcode that has letters and numbers. So yeah, these are all validation checks. So here they are, key validation checks. Character or type check, a length check, format check, existence or presence check, and even something called a check digit. So a check digit is when you use a mathematical operation, add up the numbers of a barcode, and the last digit should represent a 0 or a 1, depending on how you've done the mathematical function. There are different versions of it. You won't be asked to demonstrate a check digit, but you can put it down if you really want to. So validation checks are all done before data is entered. If data does get entered, we need to verify that the information has been checked. So we can do that by doing something like double entry. So you can get the person to enter data twice to make sure it's accurate, or you can ask them to check it visually. It's been proven just to ask people to check it. So you can just say, have a look, check your details before you submit. And also screen verification, that's the one I was talking about, where you can just check it visually. You can get Debbie to proofread it. Debbie in the sort of admin department. I always use Debbie as an example. Debbie don't exist, by the way. But you can check it. Now, algorithm design. The bread and butter of a computer scientist. Producing algorithms for fun. That's how we roll. It's why we get paid so much money, innit? Firstly, variables. What's the difference between a variable and a constant? That's my first question. Variables. If something varies, it does change. Waleed, you are on fire. Yes, incredible. Incredible. Excellent, well done. Right, now variables, they are spaces in memory, right? They contain a single piece of data, and that data has a data type. And we should be able to know, we should know now our data types. Integers, which are whole numbers, real numbers or floating point numbers are decimal points. Booleans are true and false. Characters are single digits, and strings are, sorry, a character is not a single digit. A character is a single letter, and a string is multiple letters. Okay, and when you define a variable of a certain data type, it must remain in that data type. Unless you're programming in Python, people. Python just decides whatever you give me, I'll change myself. Try that. They do that to try and be more simple and more straightforward. However, judging by some of the programmers I've seen on this live stream, who knows what you do? Sometimes it's confusing to understand what data type is in there, right? If I perform a little bit of Python and I say A equals input, enter a number, okay? What data type is A going to be? Anybody know? What data type is A going to be? Thank goodness, Ivan. Thank goodness you're here. Followed by Helios. Excellent. Right, it's going to be a string, isn't it? And that's because this thing is a predefined function that returns strings only. What would I need to do to make sure that it is a number? Preferably a whole number. How do I make this bring a whole number in? Yeah, you know it. Tougher Joe straight in there. Oh, look at that. Waleed's done. Give me the full thing. Incredible. Incredible. It makes me feel all warm and fuzzy inside. It gives me hope for the future generation, this people. Yeah, you cast it, don't you? Now, constants are pretty good, right? Constants, use them where you can, right? Python doesn't really have constants, though. It got rid of them because people don't tend to use them anymore. You try and use them where you can. Can anyone give me a good example of what a constant might be? Think of something that doesn't need to change throughout the life of your program. What type of data wouldn't need to change throughout the life of your program? Any examples in real life? Oh, okay, yeah, all right. Eye colour, possibly. John, subscribe again. Whoa, 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 whoa. This, you know what? That needs like shadow banning. That. Can I put Tuffy on a timeout? Oh, I can. Put user on timeout. Oh. Uh-oh. I actually, yeah, I put him on a timeout. I don't know how to untimeout you, Tough Vigil, but yeah, okay, that's how we roll. Now, I've got 1,000 subs, people. There you go. So in your face, Tough Vigil. You don't even have a channel. There is a channel that everyone can subscribe to called, what's it called? Tent24. Don't know if you've ever heard of it. It's fantastic. It's all about Roblox. One of my students has got like 5,000 more subscribers than me, and it makes me feel slightly sick considering the content he puts out is absolutely drivel. But there we are. There's a shout out. I did tell him I would shout out, and I've done it for him. Let him enjoy that. That was at, what time are we on? That was at 19:20. So constant. Good thing about constant is that if you change the value of the constant, it will change everywhere in your program where that constant is used. So it's very quick for changing things. Now, fine, we put that over there. Variables and constants, we use them all the time, especially variables. Now we think about scope. There is two types of scope when programming people. Can anyone tell me what those two types of scope are? Excellent. Local and global. So a local variable only exists until the subroutine in which it was created ends. There are two types of subroutine as well. We have something called procedures, and we have something called a function. Okay, procedures and functions. Procedures are actions. I like to think of them as actions anyway. Actions, and functions return values. So if you don't see return, it's not a function. A global variable is accessible everywhere. Right? It exists throughout the program execution. It can be read or written from any subroutine. The problem with that is not great for security, and the memory is going to last forever. So they are not very efficient, global variables. Anywhere you can, try and use a local variable over a global variable. Can't always get around it, but one way of getting around this problem of having global variables is to use something called parameter passing instead. What is parameter passing? That's when you have, let's do a procedure or a function called calc VAT, right? Calc VAT, and then I might put total, comma, percent, right? These, inside the parentheses, are parameters, or arguments in Python they're called. Oh, speak of the devil. Now, parameters can be passed in one of two ways. Passing by value. So when you pass by value, this is the key word to use. So you can pass a copy of the actual data, right? And that means that the original data that you passed into that procedure, function, subroutine doesn't change. You pass a copy in, the data is safe. Use it, manipulate it, output it, whatever, but the data is unchanged where it was originally pulled from. Passing by reference passes the actual memory address. So if you send the original memory address, that means you can change that value where it's stored in random access memory. And we try not to use passing by reference nowadays. We try to pass by value all of the time because it's much safer. Much safer indeed. Okay? Wonderful. Wow. Would you look at that? Would you look at that? You said you wanted pseudocode, people. The sales director of a company wishes to compare the sales in thousands of pounds achieved by her sales staff in the previous month. Design an algorithm using pseudocode. So there you go, it's been specific. We can't use flowcharts. With the following input. Number of sales staff. Now what I like to do, as I go through, right, when it says inputs, I'm going to need variables for these. So can anyone think of a good name for number of sales staff? What should I call that variable? Any idea? end sales, right? So I'll say, let's do, oh, it's going to do that thing again. Num sales staff. Num. Wow, this is so difficult with a graphics tablet, you know. You don't understand the level of skill that's going on here right now, right? Number of sales staff. Anyone know what type of data type it will have? What data type will num sales staff have? Is integer. Whole numbers. Yep. Can't have half a person, can you? Well, you can have half a person, but they won't be programming. Integer. Yeah. Sales figures for each member of staff. All right? That might be something like sales fig. Now, the algorithm should output the mean. So the mean is calculated. That's like you take the total sales divided by, it'll be the number of staff that we've got, right? Number, sales, staff. Yeah? Easy. Now the values of the sales figures which are below the mean. Oh, right. Think about this now, people, because I'm trying to think of what data structure I'm going to use. So data structures that we can use that you know so far are things like arrays, array. Dictionaries, so dictionaries. So key and value, as many as you want. And we have something called records. You might not have come across records before. But essentially, records are fields. So this is a field here. This is a field. This is a field. Now, specifically, arrays have zero-based indexes, like this. They also have names, like my array, for example. And these are called elements, aren't they? Elements. Now, an element can have one data type only. I'll say that again. Arrays can have one data type only. Lists. What about them? What about a list? A Python list is identical to an array, apart from the fact that lists can have multiple data types. So, fields can have multiple data types under one identifier. So this is called my record, and you can have multiple data types as fields. So you can have an integer in here, a Boolean value here, an integer again in here, a string, for example. And records are used for files, so file handling. Put them in files. All right? So they're the data structures that we can use. Now I want to keep and iterate and go over and go through all of these data structures if needed. So what I'm going to do is I think the mean of the sales figures, add them all up, divided by how many you've got, input the number of sales staff. Right. Sales figure for each member of staff. Okay. So what I'm picturing in my head is I'm going to have... Sorry about the line. It's just graphics tablet's difficult. 0, 1, 2, 3, 4, 5, 6, right? Let's say the person said, how many sales staff have you got? And the person said, I've got 7. I've got 7 staff. So that means I'm going to create 7 boxes, right? 7 boxes. Every person, so person number 1, which is position 0, they're going to put in their sales number, right? Oh, they've done 6 here. That's the test data we've got. We've got 6. So let's say they put in 45. 45 goes in. 55 goes in. 65 goes in. 65 goes in. 10 goes in. 60 goes in, right? Now then, how do we do that? How do we actually do that? In code, let me erase all this trash. I should have made this smaller. I've made it large on your screen so you could see it at the detriment to me. Now I've got to write like a skillful person. Get rid of that, get rid. Keep that. Okay, let's write the code for that. We'll do it down here. See if we can fit it in. Right, let's do sales. Right, sales. Now, in order for me to work and use this sales, I've already got num sales staff is integer. Next thing I need to do now is say set num sales staff. Set num sales staff. This is pseudocode, yes. Set num sales staff. And we can use 2 or equal, so I'll use 2 for this. 2 input enter num staff. Now, apologies, I'm being brief because our space is tight and I don't know what it looks like on your screen. Hopefully you can see it. Hopefully. Now, once that's done, they've entered the number of sales staff. I'm going to make my array of that. Right? So I'm going to say sales down here. Oh, jeez. Right, I'm going to say sales bracket num now what data type is my array going to be? There's the example of what it's going to hold. It's going to hold them kind of figures. Right, integer. So I've got this now. I've created this array up here, people. I've created it. It's of, if the person puts in 6 sales staff, it's going to be 6 values long. Technically 7. But we'll see, right? So if somebody puts in number of sales staff 6, it's going to create 0, 1, 2, 3, 4, 5, 6. So what you can do is you can say sales, num sales staff. You can't see this really, but I can put minus, oh, it's going to be difficult, minus 1. Right? If you don't do that, you can fix it later on, but I put minus 1 bit next to sales staff there to make sure that it'll go 0, 1, 2, 3, 4, 5 now, okay? I've reduced it by 1. Is there still 6 boxes in my array? Yes, there is. We're just starting at 0, all right? That catches a lot of people out. So I've done the number of sales staff. I need the sales figures for each member of staff. So I've got to loop through this and enter a value in each of the boxes. So I've got to populate these boxes with values. So I've got to put 45 in there. I've got to put 55 in there. So how do I do that? Now, I'm going to use a for loop for this because it's static. So I'm going to say for I equals 0. So starting at 0, going to num sales staff. So going up to 6 as per the question, minus 1. Correct, DriftKing _ YT. That's right. So I'm going to go from 0 to number of sales staff minus 1. So that's 0 to 5, because this would be 6, but I've minus 1 from it. So 0 to 5. Now, every time I do that, I'm going to say, in my array, so my array is called sales, at the position of I. So I is currently 0. So it's pointing at the first box. So at the position of I, first box, ask the user to insert and put something in there. Input sales for I plus 1, right? That's it. So we use the -1 because if I was using their data and we said, how many sales staff have you got? They put in, I've got 6 sales staff. And we go, okay, I'm going to make an array of 6 people. When you make an array of 6 people, you have the position 0, because that's where we start. We go 1, 2, 3, 4, 5, 6. If you count that, there's 1, 2, 3, 4, 5, 6, 7 numbers there. 7 numbers. We need to -1 it. So we need 6. We need 6 in total. This is for WJEC, EDGECAS. It's not OCR, no. Right. So that's done. So that line there is probably one of the most difficult lines for students to learn. All right. So sales, in the sales array, at the position of I, which is 0 on the first run, input the sales staff for, so you input 45, right? When it gets to next I, it's going to loop and go in again. Now at the same time we're doing this, what we need to do is add up the total. So once it's been put in sales I, 45 is now in that position, so 45 will be there on the first pass. How about we add it all together at the same time? So total equals sales. Oh, that's wrong. 1 second. I'm getting ahead of myself. John recommends you take a pencil in to do pseudocode. Total equals total plus sales at the position of I. Okay? That is going to add them one by one. Add 45 on the next pass through the loop. It will add 55 on top of that, 65 on top of that. And if I didn't have total here and here, it wouldn't add up and accumulate. It wouldn't add up each number one after another on top of each other. So I need the total for the mean. That's why I've done that. Values of sales figures below the mean. How many sales figures are below the mean? The lowest sales figure. The lowest sales figure. Now I've said total there, but I haven't declared it. So I need to... Total is integer. Add them all together. So I made the variable at the top for that. And I'm going to run out of space here. So has anyone got any questions so far? I've got total, number of sales staff. They input the number of sales staff. I create an array of that size. I loop 6 times for this person. And I input sales one by one into my array. I have declared the array. It says here, sales, num sales staff -1 is integer. I've declared an array of that size, -1, and it's of type integer. Done that? Wouldn't you have to declare the variables total? Okay. You can do, Aaron. The only reason why I haven't is because the default of declaration is already 0. Yeah. So if you wanted to be, you could be really precise and do that if you wanted to. After that, I've populated the array now. I've added up the total, and I'm going to work on this one here, the lowest sales figure. So out of those numbers, which one is the lowest sales figure? It looks to me like it's 10. So what I need to do is I'll say min is integer. So min's default value will be 0. And I will say if, yep, you need a selection statement now, people. If the thing you've just entered, which is called sales array at the position of I, right? If the thing you've just entered is less than the minimum value I've got up here, then I'm going to set that minimum value up there to equal sales at the position of I. So you're going to overwrite with the lowest value. Yep, very good. Now the problem here is, people, which I've said numerous times, the default value is 0 for minimum. So what Hamza was saying up there before, is 45 less than 0? No. Is 55 less than 0? No. Is 65 less than 0? No. 65 less than 0? No. 10 less than 0? No. 60 less than 0? No. So you'd say minimum is integer, so set the minimum, set the minimum equals 99999 ... Right? Set it to a stupidly high number, and that means that the first pass through this, 45 will be the lowest number. And then 55 comes along, it's not the lowest. 65, not the lowest, not the lowest. The lowest, that overwrites 45, 60, not the lowest, and then it stays at 10. Okay, could go something like 200 if you want to. Oh my goodness, oh my goodness. Done that, right, so I've done the lowest sales figure. After I've finished that now, next I, end my if statement. Done. I've done that as well. Right, so the mean of the sales figures, mean. Set mean is float. What's the calculation for the mean again? I think I wrote it before. Total. Now it has to be outside of the loop, this. Okay, outside of the loop. So total divided by number underscore sales staff. I thought we were done here, people. 6 marks this is worth. Now, this is an old spec question. Shouldn't the input be in the loop? What input? This one. Sales staff. No. Now, this is an old spec question, and this will be worth more now. So we see these kind of pseudocode questions worth a minimum of 9 marks and a maximum of around 11 now, depending on what's asked of you. This one, I'll top this up at the end and tell you what this should be worth, but for the types of skills that's needed. Now, I need the mean of the sales figures, then I need to check the values of the sales figures which are below the mean. Now, I need the mean first before I can check those sales figures. So now I need another for loop, just like before, for I equals 0. Num sales staff minus 1. Okay. Then I'll say if sales, the thing in your array at the position of I, is below the mean, so less than the mean value I've calculated, what do I need to do? The value, so output those values. Okay, if, then I'll output brackets, speech marks, oh this is messy, below mean. Right, now if you're writing pseudocode in your exam, add 1 to a variable counting the number of sales. Yep, that's true. So if this is your exam, if you don't put a meaningful output, i.e. text with your output, You won't get marks for this. You need meaningful outputs. If you just output a number like 6, no one's going to know what that means. So you have to put text with it and concatenate it. Squish it together using a comma or a plus, and then output the total. So below mean, and then my below mean amount. Oh, sorry, not the below mean amount. The actual value below the mean is sales at the position of I. Okay, close my bracket. So I output each one. That's outputting the values. I've calculated the mean now. And now I need to work out how many sales figures are below the mean. So like Aaron was saying before, yeah, PHP we use a full stop, yeah, but this is pseudocode. So how many sales figures below mean? So I'll put below mean is integer. And then I can say here, below mean equals below mean plus 1. Now, another way of writing that line is below mean plus equals 1, if you fancy. And then we end the if. Okay, end the for. Well, next I. And then here, all we've got to do is output. Oh my goodness, my writing's gone to pot. Output no below mean, comma, cause speech marks, comma, below mean. Wow, that is incredibly untidy. Apologies for that, people. Next time I'll give myself more space. Right, now, you say 6 marks. So what skills have we got? Let's see how many this should be worth nowadays. So we've got here variable declaration and assignment, 1 mark. We have the creation of an array to a specific size based on an input, 1 mark for that. Then you've got the first for loop, that's going to be 1 mark. You've got inputting to an array, that's going to be 1 mark. You've got the calculation of totals, that's going to be 1 mark. You've got selection statements being built, 1 mark. Checking for the minimum, that's included in that mark. You've got the mean calculation, that'll be worth a mark. You've got the second for loop, and then checking that the sales are below the mean for another mark. And you've got a final mark for all of your outputs in there as well. So that would be anywhere from 9 marks plus. Did you output the lowest sales figure? I did not, Res Daddy. So yes, thank you very much for spotting that. I did not output the minimum. So you'd need to do that somewhere else. So you'd say output min is min. Okay. So anywhere, probably between 9 marks. You might get 11 out of that, depending on what they look for in the mark scheme. Okay. Yeah, output the mean as well. Clearly I've not outputted anything, have I? Always read the question. I should have done that. Output the mean. Thank you very much, Ibrahim. So would it output the increasing value of below mean? No, this, because it's outside the loop, so because it's after the next here, this arrow, it's very messy, I do apologise. Out here, it's it won't output it every time, it'll do it once at the end for this, okay? Now, there are plenty plenty of algorithms to have a go at. If you want answers, they're all in here as well. I can send these slides out to people if they want. It's like 700 slides long, people, though, so brace yourself because it covers every topic ever. I will be doing another live stream later on. Okay, I thought you might want it, tougher Joel. Things that you need to know for the exam for sorting and searching algorithms. You need to know what they are and how they work, so you might need to describe them. You need to be able to dry run them, given data. You need to be able to pseudocode them, and you need to know the best and worst case scenario as well. Okay, now for those people that want these slides, etc., I might have to just send you a Google link so you can download them because it's so large, I don't think I can just put them on Google Drive anymore. So these slides will contain the bubble sort algorithms, insertion sort algorithms as well. You don't need the quick sort algorithm until next year if you make it, but that pseudocode there, one thing a few of us have been doing, especially in my programming class, we went back to the bubble sort and we reprogrammed it again, went back to the insertion sort, we'll reprogram that again, because converting pseudocode to code actually is beneficial. It's memory recall and it's sequencing of skills that we learned earlier in the year, which are very powerful revision techniques indeed. So insertion sort as well on there. And in addition to that, insertion sort, linear search, binary search is in there as well. There's the binary search using the loop. I've broken that down into steps for you. I thought I'd have more time to do this. Unfortunately, I have not. I've got videos on all of these, and I've done a little comparison for you as well to help you out in your exams to be able to describe them between each other. All right. In addition to that, a couple of things that you might need to be aware of are the three main programming constructs that we have. So we've got sequence, we've got selection, and we've got repetition. So sequence is when code goes in order. Selection is if statements or something called case statements, which are essentially the same thing as if statements. It's a condition. If the condition's true, carry out the true part. If it's false, carry out the false part. Repetition, we only have two types of repetition in Python, for and while. For is a static loop, which loops a set number of times up to a certain amount. While loops indefinitely until a condition is met. A count value is what I did before in pseudocode. So think about something like next I, for example. So next I, that counts up I, so it basically increments I by 1 every time. If you've got a count variable, if you name a variable called count, for example, and you say count equals count plus 1, that is a count variable. In our code then, we counted how many sales were below the mean, for example. That is a count. Now, in addition to that, we just don't call it a count, but this is the formal definition of it. Here, we've got a rogue value. Now, a rogue value is what we call a terminating condition. And it's basically what stops a while loop. That's where we see these rogue values the most. So while something is true, or while something is false, or while something is less than something else. All right? I think Ibrahim is like my biggest fan. ESP Task 4 walkthrough, please. Oh, no, it's time. Time is a problem. Time is a problem. All right, so if you look at this stuff, sequence, you're looking for code that flows in order. You're looking for if statements, and you're looking for selection. And if you've got iteration, you're looking for loops, etc. All right. Now, on top of that, if I said to you, what is an arithmetic operator? Or arithmetic? Anyone know? Arithmetic? Calculations, yeah, such as symbols used. Yeah, okay. right? So, oh, Helios is going for the big ones there. So they're going for div. So that's div that keeps the whole number. Percentage is modulus division, which keeps just the remainder. You've got plus, minus, divide, multiplication. You've even got the powers, so the hats that go on there as well, or the stars, yeah. You know, tell me what a relational operator is then. A relational operator. Oh. Oh, Ibrahim's on a timeout. Oh, that's a shame, innit? Oh, how did that happen? Oh no. Right, Jaden's put an equals equals. Very good, very good. Equals equals is a comparison operator. Any others? Relation, not equal to. Excellent. What other ones have we got? Yeah, greater than or equal to, less than or equal to, greater than, less than. Yeah. All good. They're relational operators. Yeah. So they're normally used for conditions in if statements, while loops, etc. Then the logical operators. There's only 3 of these that we tend to use, but there are more in real life. 3 that we tend to use. Anyone give me a logical operator? Yeah. And, or, not. Okay. So don't. Normally, if you're asked about those, you normally get a section of pseudocode, and you just get asked, state the relational operator or state the line that the logical operator is on, etc., etc. Okay. Packets being lost. What are you on about, Drift King? What constructs do we see here? Sequence, selection, or iteration? What do you think? Can you see any sequence? Can you see any selection? What do you see, people? What do you see? Nope, inputting. Right, so, for example, if you were asked to work out what was going on here, this stuff here, this is Visual Basic. Yeah, I know. But the point is, you don't see any ifs, do you? You don't see any ifs, you don't see any fors, and you don't see any whiles. So the only one this could be is the code will flow in order. The code will flow in order. So that is sequence. If you look at something like this, for example, you've got selection in here, you've got selection, you've got a little bit of sequence where the code will go in order. In this one here, does anyone know what this is called? You've got an if statement here, and you've got another if statement inside that one. Does anyone know what that's called? Excellent. A nested selection statement, okay, or a nested if statement. Excellent work. We can also have nested for loops as well, or nested iteration. This is a standard iteration piece. And then in this example here, we've got nested iteration as well. So all the way down here, all the way down here. Okay? Excellent. Now, we're coming up to the end here. So I can send these out. Definitely, nested means a statement inside another one. All right. Now, a couple of last bits of advice in the last minute here, people. Definitely look at binary. Okay, binary has lots of things that could be covered, from converting binary, standard binary, converting binary to hexadecimal, binary addition, multiplication, addition or subtraction. We've got negative and positive binary. So negative binary comes in 2 forms. We've got sine of magnitude and 2's complement. We need to be able to perform that. And also floating point binary. What students tend to forget when they revise binary is that there are things like clearing, masking, and encryption as well, using AND, XORs, and XORs. Yeah, AND and XORs, that's it. Yeah, masking, clearing, encryption. So I'd definitely have a look at that as well. Have a look at absolute and relative errors. Have a look at shifting, arithmetic and logical shifting as well. And I've put in there on these slides as well for you, just before we go, I have put for you exam questions, but those people that were terrified of Boolean algebra. Oh, simplex connections, very good. Yes, yes, yes. Actually, did I just click? No. Well, somewhere in here, anyway, I've put some new Boolean algebra questions from recent years. Okay, so tomorrow morning when I get into work, I will... Actually, I'll do it straight after this stream because that's how dedicated I am. I'm so dedicated. I'll put these slides onto Google Classroom and I'll send it to all students because I'm so cool like that. All right. I know it doesn't. DriftKing_YT. Right. Now, people, all I can do now at this point is wish you the best of luck. I'll see my computer science groups tomorrow, both of them. If you've got any more questions, please do ask me. You've got this in the bag. All you have to do is focus and use your revision techniques. Please don't just reread. Please don't just highlight. Please, they are proven not to work. You have to practice exam questions. You have to low stakes test yourself. You have to sequence. You have to repeat. Flashcards are good. All that sort of stuff. All right. Thanks for coming. I do appreciate it. Hopefully you found something useful in those 2 hours. I'll see you tomorrow. Have a good night, people.